Hello again, everybody. So here we are with our review of solving equations. Now we're going to do 2 days of this because we've got a whole bunch of different types of equations that we need to review. But we're going to start with the most basic. We'll get a few different types in today. I think there's one that's kind of new. I mean, some of you have solved absolute value equations in the past. Others have not. So we'll go over those a little bit, but they're not too difficult, okay? But the first ones that we're going to learn to solve today, or we're going to review to solve today, I should say, are the linear equations. Now, those are first degree equations. Everything is only raised to the first power. There's no variable that has an exponent of higher than 1, okay? But when it comes to these, as in these two examples here, we want to first, let's distribute here. I've got 3x minus 6 is equal to 5x minus 5. Now, really the only step here is isolate that variable. So I prefer the variable on the left side, which means that I'm going to move 5x to both sides. And I'm also going to add 6 to both sides. This now gives me, those will cancel out. Negative 2x is going to be equal to negative 1. I can divide both sides by negative 2 here. Now, what does that do for me? That's just going to give me an answer of x equals 1/2, okay? So that's it for that one. Real basic stuff here. I don't think we need too much explanation other than, make sure that if you divide, negative divided by negative is positive, positive divided by positive is positive. But if you have one of each, that's going to give you a negative answer. That's really my only hints for you there. Now, this one here, I know we're talking about first degree equations. And, if you FOIL out here, you're left with 2x squared minus 2x minus 1x plus 1 is equal to 2x squared minus 5x minus 10x plus 25. I'm kind of running out of space there, sorry. I thought you said that we were only going to have exponents of 1. Well, I am just going to neaten this up real quick. 2x squared minus 3x plus 1 is equal to 2x squared minus 15x plus 25. And to answer your question, you're right, I did say that. And actually, let's see what's going to happen here if I try to bring over some terms to the left side. If I subtract 2x squared and I add 15x to both sides, well, what happens to those 2x squareds? Okay, so if I were to say that this is it, okay, these 2x squareds here cross out, and these 2x squareds here cross out. That doesn't, because of that, I'm left with, this one's going to give me 12x plus 1 is equal to, I move that, is equal to 25. Well, this is exactly why this is still considered a first degree equation, because even though I had some x squared terms, they all cancel out at the end, okay? But let's continue to solve this. I'm going to subtract 1. I get 12x is equal to 24. Divide both sides by 12, and you'll get that x is equal to 2, okay? So that's what we're talking about. Those are all first degree equations. Get rid of your exponents, get rid of your parentheses, excuse me. And from there, it's just a matter of isolating your variable and solving, okay? So let's move forward. Now, this is the ones that I was talking about. These could potentially be new for some of us. For absolute value equations, what we want to do is we want to isolate the absolute value term. If it's possible, do it on the left side, just because it's the way that we're going to teach it this year. It makes your life a little easier, just with following some steps. Then you remove the absolute value brackets, and then we're going to split it up. One side, we're going to do exactly how we see. The other side, we're going to negate the right side. When we say negate the right side, we mean the entire right side. But here's what I'm going to do. For question letter A here, is that absolute value of x plus 4 isolated? It is. There's nothing else on that side, so we're going to leave it. I'm going to go straight to branching off here and solving two separate equations. I solve x plus 4 is equal to 13, and I'm also going to solve x plus 4 is equal to negative 13. So it's the same exact problem, the same exact absolute value piece. However, I'm solving it 2 separate times. On this side, I subtract 4. I get x is equal to 9. On this side, I subtract 4. I get x is equal to negative 17. However, there is an important step here that's not written down, but you must do a mental check. Make sure that your answer works out, okay? Because there's a possibility that with these absolute value brackets, not everything's going to cancel out, okay? So if I plug back in here, the absolute value of 9 plus 4 is 13. Absolute value of 13 is 13. That's going to work out. So this is a good answer. Now, like I said, it doesn't need to be written down. I'm just doing that so that you guys can see what it is I'm talking about as I do it. You can do this in your head, okay? But if I look here, negative 17 plus 4 in absolute value brackets, is that equal to 13? This gives me the absolute value of negative 13 is equal to 13, and that's also going to work out. So this is also a good answer, okay? There are times that when you do your mental check, though, you might have to reject one answer. You might have to reject both answers, in which case your answer is just no solution. So let's see what we do in our next example here, okay? But like we said, is the absolute value term isolated in this problem? And it is. So again, it's just absolute value of x plus 2 on one side. So we're going to go straight to branching off and splitting here. The left side I'll solve as x plus 2 is equal to negative 5. The right side I'll solve as x plus 2. Negative 5 is the same as 5. Okay. So if I subtract 2 here, I get x equals negative 7. If I subtract 2 here, I get that x is equal to 3. But what do we still have to do? We still have to check. Now, I'm going to do the same thing where I'm going to check it by writing it down, but there's nothing stopping you from just doing this in your head as we go along. Okay, so when we go and check, I've got negative 7 plus 2 is equal to negative 5. We always check with the original. I don't know if I said that before, but this is going to give me the absolute value of negative 5 is equal to negative 5. Now, if you remember anything about absolute value, this is going to be 5 is equal to negative 5. Now, this does not work out. I need to reject this answer. This one won't work. So let's see, maybe this one does. 3 plus 2 is equal to negative 5. Sorry, everyone. Absolute value of 5 is equal to negative 5. Now again, I'm in the same situation here where I get 5 is equal to negative 5. This one doesn't work out either. So what happens when both reject? This is what I was talking about before. My answer is just no solution. And you could write your answer as no solution. Another thing we could do is we could put open brackets. Or a third thing that we could do is we could put the 0 with a line through it. All of those mean no solution. So it's completely up to you. But those are absolute value brackets. Okay. Then we've got quadratic equations. We have so many different ways to solve quadratic equations. We're going to go through a few different methods here. The first one that I'm going to use, regardless of which method you want, you do have to put into ax squared plus bx plus c form, however. And then you can factor, you can square root, you can use a quadratic formula if you need. It's up to you, but are there factors that add to negative 2 and multiply to negative 8? And there are. It's going to give me x minus 4. X plus 2 equals 0. From there, what's that going to do for me? X minus 4 equals 0. Therefore, x equals 4. I've got x plus 2 equals 0. And that's going to give me x equals negative 2. Both of these answers are going to work out. So that's part of the solution. Over here, now I'm not in the proper form yet, so I do have to do a little bit more work before I can factor this one. Let's move this over. I've got 2x squared minus 3x minus 5 is equal to 0. Depending on which method you preferred in that first lesson, you could factor this a few different ways. If you're good enough at it, I know I haven't reviewed it yet, but you can go straight to quadratic formula. There's nothing stopping you from that. I'm going to multiply, though, first by last and get negative 10. Are there factors of this negative 10 that add to negative 3 and multiply to negative 10? So here's how I do these. I'm going to put 2x blank equals 0. Now those factors of negative 10 that add to negative 3 are going to be negative 5 and positive 2. Now, I'm not allowed to just multiply by 2 because I want to. Like, all right, that made my life easier, but that doesn't mean that I'm allowed to just do it. So what's the opposite of multiplying by 2? Well, dividing by 2. So one of these has to get divided by 2. And if you look, one of them should work out nicely. So if I divide the right one in this case, or you guys know that multiplication, you could put them in either order. So if you had put that one first, that's fine. But this is going to give me x plus 1 over here. And then from there, I can solve. I get that 2x minus 5 is equal to 0. You guys are all smart enough as honor students to understand that this one's going to give me x equals 5 halves. This one, x plus 1 is equal to 0, is going to give me negative 1. Both of those answers will work out, okay? So we don't have to worry about checking these quadratic ones here. Moving along, I've got 2x squared minus 6x equals 0. Well, this one is not a trinomial, it's a binomial. With any factoring, the first thing you want to look for is a GCF, and if I GCF out of 2x, what am I left with? Well, I'm left with x minus 3. From here, I go straight to my t-chart. 2x is equal to 0, and therefore x equals 0. X minus 3 is equal to 0, and therefore x equals 3. Those answers both work out. Like I said, you do not need to check these quadratic ones, okay? So that's our factoring method. Now that's something that you guys should be very familiar with. In St. Anthony's, we have drilled you upon drilled you with factoring. I know that for a fact, so you guys should be okay with those first 3 ones there. These next, the square root method, some people may have gone in depth a little bit more than others, but it's literally just that. Like if you see you've got a perfect square, there's nothing stopping you from just taking the square root of something, except you do have to remember that whenever you take a square root, it is positive or negative of that solution. So this first one is very simple. I've got x squared equals 9. Well, these are very obvious. Like x squared is a perfect square, 9 is a perfect square. So if I take the square root of them, I get x equals. Now everyone always says the square root of 9 is 3, and unfortunately you're wrong. It's not 3. It's plus or minus 3. Okay, so you do have to be careful of that whenever you take the square root, you do need that plus or minus symbol there. Okay, now question B has a little bit more work for this square root method, but it's simply just let's add 12 to both sides. Now I have 2x squared is equal to 12. X squared, I want to be alone, so I'm going to divide both sides by 2. And now I have x squared equals 6. Well, 6 is not perfect, but x squared is, so I still want to solve this using the square root method. Okay, and when I do that, I'm going to get the left side is x. The right side doesn't simplify, it stays radical 6. However, what is the square root of 6? It is positive or negative square root of 6. So it is something that you have to be careful of. Anytime you take the square root, make sure you write down that plus or minus symbol. It is super, super important. In fact, so important that I'm actually going to highlight it right here and right here. Okay, when you take the square root, you must put plus or minus. For this last example, I've got a parentheses is equal to some number, but that parentheses is squared. Now this is going to come up a lot when it comes to completing the square method of solving things. It's something that we will be using, so it's something that let's practice it. But I can go straight. So I've got this x minus 3 squared is equal to 8 here. I'm going to go straight to square rooting both sides. And if I square root both sides, when you square root a square, you're left with just what's on the inside. When you square root radical 8, you're left with plus or minus 8, radical 8. Radical 8 we do know simplifies though. So we're going to simplify radical 8 to plus or minus rad 4, rad 2. Radical 4 is perfect, so this is going to be plus or minus 2 rad 2. And now I'm going to bring down the rest. And now how do I solve for x here? Well, very simply, add 3 to both sides. Can I combine that 3 and that 2? Absolutely not. That's not a thing. That's never been a thing. This is just, as you see in this method here, when we're solving using this method right here, if I take the square root, my answer is going to be m plus or minus. So what's going to happen here is that I'm going to have 3 plus or minus 2 radical 2. Okay, so that's what we get when we solve using the square root method. It's a good method that it doesn't come up too often. You guys may or may not have seen it before in the past, and that's totally okay either way. It's just another thing to help you guys out, another resource for you to use this year, okay? But the last one, I don't really think that we need to go over this that much, but since I'm going over everything with you guys, I definitely will. It's just the quadratic formula. The quadratic formula is, you've been doing this since Algebra 1. It's just a matter of, are you neat and organized? You need to list things here. First things first, ax squared plus bx plus c equals 0. If you're not equal 0, you can't solve using this, but it's just a matter of plugging in that. So I've got a is equal to 2. I've got that b is equal to 1, and then c is equal to negative 2. If I go in and plug in here, negative b plus or minus the square root of b squared minus 4ac all over 2a. And it's just a matter of plugging in and evaluating correctly here. So this is x equals negative 1 plus or minus, this is going to be 1. 4 times 2 is 8 times negative 2 is negative 16. So this is going to be 1 plus 16 in here over 4. My answer should be x equals negative 1 plus or minus radical 17 all over 4. Okay, that's my answer there. I'll practice the last few with you guys, but again, me practicing it doesn't really do anything for you other than to check yourself. If I look at this, that is ax squared plus bx plus c equals 0, so I can really go straight into a is 4, b is negative 4, c is negative 7. If you want, we do teach this in Algebra 2, you could go a little further, that negative b is equal to 4, b squared minus 4ac, well, that's going to be negative 4 squared minus 4 times negative 7. What that's going to equal should be 128 there. And that 2a is equal to 2 times 4, or just 8. And now you've got everything that you need. So you could do x equals negative b plus or minus a square root of b squared minus 4ac, which we've already evaluated, all over 2a. From here, 128, oops, what just happened there? 128 is going to be equal to 4 plus or minus radical 64 radical 2 all over 8. This is perfect. So what does that do for me? That gives me x equals 4 plus or minus 8 rad 2 over 8. Now, if we check in here, does everything reduce? Everything in there reduces by 4, and so that's going to be 1 plus or minus 2 radical 2 all over 2. And there's my answer. Hopefully this is coming back for you guys, because again, I really can't stress this enough. This is nothing new. This is just something of, are you neat? Are you organized? Are you following the formula that you should know since Algebra 1? And if you are, that's great, okay? And then the last problem over here, we'll do one more together. If you look, I'm not set up properly. So because I'm not set up properly, I do need to do a little bit of work here. Let's subtract 4x on both sides. I've got 3x squared minus 4x plus 2 is equal to 0. Now I'm in ax squared plus bx plus c form. A is equal to 3, b is equal to negative 4, c is equal to 2. I'm going to do this other thing where we went negative b is now equal to 4. B squared minus 4ac is going to be negative 4 squared minus 4 times 3 times 2. That's going to leave me with 16 minus 24, which is negative 8. 2a is just going to be 2 times 3, which is 6. And it's just a matter of plugging in. X equals negative b. Plus or minus the square root of b squared minus 4ac all over 2a. Now, the big thing here to know is that when you've got those negatives in the, inside the radical, remember, this actually means that there is no real solution, but we can simplify this. So let's go on and make sure we do that. I'm going to get 4 plus or minus radical negative 4 radical 2 all over 6. This is going to give me 4 plus or minus 2i radical 2 over 6. I check here. 4, 2, and 6 all reduced by 2, giving me an answer of 2 plus or minus I radical 2 all over 3. I believe that's our last problem. Like I said, quadratic formula is just a matter of being neat, organized, and plugging in where you're supposed to. These are our first 3 real equations that we wanted to review. We had those linear problems over here where all we're going to do is get rid of our parentheses and isolate the variable. Some of these may have been new for us. Remember, with absolute value equations, we want to make sure we check, and it can be a mental check. It doesn't have to be written down like I showed, but you do want to give some sort of check with those. And then with quadratics, those are those ax squared plus bx plus c equations. Like I said, you guys have seen those for so long now that it doesn't matter if you choose to factor like these 3, use the square root method like we did in these 2. If some of that seems too unfamiliar with you, although I do think that's faster, at the end of the day, if you really just wanted to use quadratic formula, you can. There's nothing stopping you from that. Or if it's just plugging into the quadratic formula like we just did. These are all things that you have done before. So it's stuff that hopefully this review wasn't too bad for you guys. Regardless, I do hope that it made sense for everyone. We will see you soon. And if you've got questions, as always, make sure you are asking. I'll talk to you later, everyone. Bye.